One of the beauties of C++ language is that it gives you the opportunity to define your own data types. And it gives you this opportunity with a lot of power and flexibility. And we all know that with a lot of power and flexibility comes also a lot of responsibility. And part of that responsibility is covered by knowing basically the concept of copy semantics, which is the subject of today's video. And by the way, copy semantics is sort of an old subject in C++. It already existed before the modern C++ era, which is C++11 and onwards. But nevertheless, it's still a very relevant topic, and you need to take care of this stuff when you're working with your own data types. So without further ado, let's jump into some code examples. Right now I have my main.cpp, which has nothing but just the main function, and it returns 0. Let's say I want to do some particle simulations. I say class particle. I want to have my own particles. And then I want my particles to have a certain diameter. So I explicitly say star d, which let's say it's diameter of particle in millimeters. I want to be able to inject some particles with certain diameter. So I say particle double diameter. And I say d is equal to new double and diameter. Just like that. And now I want to be also able to destroy my particles. So let's say my particle is getting destroyed with any reason, like when it gets out of my simulation domain, or when some physical phenomena happens, or for any reason my particle is getting destroyed. Since I allocated some stuff on the heap, I need to also free up that resource after my particle dies. So I define a destructor, and I say delete d. But before doing that, I can also put a little sort of a statement that destructor is called to make sure that when this thing is getting executed. So now if I go to my main function, and if I want to inject one particle as P1 with a size of 10 millimeters, and let's say I want to generate another particle, but this time I want to generate it with P1. My particle is P2, but I want to sort of initialize it with P1 to have the same size. And right now Clang is complaining about these two because these constructors are marked as private by default in classes. So I marked them as public, and now Clang is happy. So note that I haven't done any computations or any sort of a specific task. I just injected two particles, one with a diameter of 10 millimeters, and the other one is initialized with the first particle. Let's see what happens if we compile this code and if we run it. So holy moly, I get a malloc error that it says pointer being freed was not allocated. And then I got two destructor calls. So first things to address is that why do I get two destructor calls? And this is sort of straightforward because main is a function, and just like any other function, when we reach end of scope, the objects or the resources that were allocated or that were used inside that function needs to be destroyed, and hence P1 is calling its own destructor and P2 is calling its own destructor. But why do we get that error that we are freeing up memory that we haven't even allocated? So let's inspect this thing in a little bit more detail. Let's print p1.d. I want to see what memory location my p1.d is pointing to and what memory location my p2.d is pointing to. If I compile this and I run it, you see that both of them are pointing to the same memory location, and that is why you're getting this malloc error. Why? Because P1, when the destructor of P1 is getting called, it frees up that resource that it already allocated, and then P2 tries to free up the same resource that was already freed up. So why this thing is happening? This is happening because, as I said, with a lot of flexibility comes also a lot of responsibility. And that is because C++ by default makes a shallow copy of your objects. So here I try to generate a P2 particle. I try to inject a particle, but I try to use P1. And what I meant was I want to have a copy of that data, which is double in this case, the diameter of the particle, but I want to have my own sort of memory location. I don't want to point to the same memory location which has the value of 5, but I want to have a new location with the value of 5. So that is the subject of copy constructor, and you need to take care of this thing if you're having resources like pointers in your data types or in your classes. So the way I can also say like copy constructor. And the way we define it is by saying particle and then const particle reference other. That's the other particle. And what I want to do is to make sure that I get a new memory location with the same data that the other has. So this is, I'm allocating on the heap a new memory location which has the same sort of data as the other one. So with this thing, with the copy constructor now, if I compile my program and try to run it, you see that this thing is working completely fine. I could also put a message right here to make sure that this thing is getting called. Let's say std cout, and then I say copy constructor is called. Whoops. And let's compile this and run it. You see that copy constructor is called and the destructor is called twice. And now these memory locations are different from each other. Note that this problem doesn't only happen when you try to initialize, for example, P2 with P1, but it can also arise when you are sending stuff by value. What do I mean by that? Let's say I have a function here called particle grabber. And this particle grabber wants to do something to my particles, but I send stuff by value. I don't send stuff by reference. So this thing wants to do some analysis, but it doesn't need, let's say it doesn't need the reference of those particles. I'm sending stuff by value. So let's see what happens if we do that. Let's get rid of these two memory addresses, and I want to use my particle grabber sort of function. I pass in P1 for that, and let's compile this. Whoops. And let's run it. You see that copy constructor is getting called twice. Why is that the case? Because particle grabber gets the stuff by value, and we have said this over and over in our videos that when you send stuff by value, the compiler basically sends a copy of your object or of your data. And when the compiler wants to generate the copy, it uses the copy constructor that you explicitly defined right here. And that is why we are getting that copy constructor is called twice. So the same way that we have a copy constructor, we can have also another scenario, which is a copy assignment operator. And how do we define this? We say particle reference, and we say operator. That is the equal or the assignment operator, basically. And that is a const particle the same way other. First thing we need to check is that we are not basically assigning to our, let's say, own object, or let's say P1 equals P1. We are not assigning to the same object. So we do that by saying this is not equal to ampersand other. And if you make sure that this is another object, then first we need to sort of allocate the memory to be sure that nothing is going to go wrong. Let's say new D, and that is new double, which has other.d. And now we want to basically delete the resources that we already have, and we delete our D. And finally, we assign new D into D. So, and then in the end, of course, we are returning a reference right here. We need to return this. And to make sure that we see that this thing is getting executed, I put also a little statement there. We say copy assignment operator is called. And then I say stdn line. So, and when do we have this situation? I'll give you the example right here. Let's say I initialize my P2 with a size of 5, and I want to see my size printed. So I say P2 size or diameter equals to, and then I say, of course, I need to say star because D is a pointer. So I say P2.D. And then I want to do the same, but before doing that, let's say for any reason, my P2 needs to expand its size and it needs to get as big as particle 1, so with a diameter of 10. So I have two objects which are already initialized, and now I want to use the assignment operator to give the same value of diameter for P2 as same as P1, which is 10. And now we're going to see after this assignment what is the P2 diameter. Let's see which, here in this case, the copy constructor is not used, but the copy assignment operator is getting used. So let's take a look at this. I compile this and I run it, and you see that the diameter was first 5, then copy assignment operator was called, and then P2 diameter is now 10. And now we have the two destructor calls. So that is also a copy assignment operator. There we go. This is copy semantics in C++. And there was also this very important rule, the rule of 3. Prior to modern C++, we had the rule of 3, which meant that if you are basically defining one of these, either destructor or copy constructor or copy assignment operator, then most probably what you mean to do is to define all 3 of them. Because in order to be safe and in order to make the user sort of make less errors in your program, then you need to basically take the responsibility and define all 3 of them: copy constructor, copy assignment operator, and the destructor, to manage your resources with your own custom data types. So I hope you learned something with this video, and I hope to see you in the next one.